Hi dears, welcome to my channel. Today we are discussing part B of electricity. In part A we have discussed a lot. Now in part B we are discussing these things. What are they? About rheostat, about Joule's law, applications of it like electric bulb, electric fuse and then heating element. And then again about the power, commercial unit of energy, and the last topic is efficiency. Shall we start the class? The first and important one is about the rheostat. What is rheostat and how it is working? What is the working principle of the rheostat and in which all fields it is used? All these we are discussing here. What is rheostat? It is the device used to control the current. It is used for controlling current. How it is able to control the current? By varying the resistance. It is mainly based on Ohm's law. According to Ohm's law, we know that if the resistance is changed, the current also gets changed. By changing or by varying the resistance, how can we control the current? This is the working principle of this rheostat. How is it working? We can see. The current is entering into this metallic bar and reaches this wiper. The wiper is directly connected to this metal coil. When it enters into the metal coil, the current passes through these coils. The current passes through these coils and at the end, it reaches out. So what happens? To this much extent, the current has to pass. As the current has to pass, resistance also will be there, isn't it? So when the current is coming out, we will get a value of current. But if we are changing the wiper from this position to this position, what happens? Much more length the coils will be, isn't it? As the length increases, resistance also gets increased. By this way, the current will be what? Current will be reduced. The amount of current will be reduced because of the higher resistance it is allowing. If the wiper is in the border, what happens? Most of the current will be coming out without any obstructions. As we are changing the position of the wiper, the current also gets varied because of the variable resistance this rheostat is offering. Okay, ma? So, this is the device. What is the rheostat, ma? Actually, it is the device used to control the current by varying resistance. Okay. So, where we can see this rheostat or for what all applications it is used. This rheostat is used to verify Ohm's law. It is also helps to control the speed of electric motor and it is also used in meter bridge. Now the important term is Joule's law. What does the Joule's law states? Joule's law states that heat produced in a conductor carrying current is directly proportional to the square of the current passed through it, and it is also directly proportional to the resistance offered by the conductor, and it is again directly proportional to the time period, means the time through which the current is passed. Okay. The heat produced is proportional to I square RT. This is Joule's law. Can you prove this? Yes, we can prove it. From where we will start? We will start with voltage. V. We already know one equation. V is equal to W by Q, isn't it? We already know this equation. Okay. V is equal to W by Q. So what will be W? W is equal to VQ, isn't it? W is equal to VQ. Here, is there any importance for W over here? There is nothing. W is not here at all. Actually, W is the work done. We already know that the energy produced is equivalent to work done. How can we calculate the energy? By seeing the work done, we can calculate energy. Here, heat is the heat energy, isn't it? This heat energy is equivalent to what more work done. So, we can relate the H as W is equal to what more? It is VQ. Can we change V? We know Ohm's law states that V is equal to IR, isn't it? V is equal to IR. Then Q is equal to what, ma'am? Is there any relation for Q? Q is equal to, we don't know. But we know I is equal to Q by T. We know, isn't it? I is equal to Q by T. Therefore, Q is equal to what, ma'am? Q is equal to IT, isn't it? So, we can relate this one and this one instead of V and Q. So, the answer will be I R into I T. Make it capital T is equal to I square R T. This is what, ma'am? This is the equation. Joule's law. This is what Joule's law states. Okay, what does the Joule's law states? Heat produced in a conductor when current is passed is proportional to the square of the current and resistance and also the time through which the current is passed. Okay, ma? Is there any application for this Joule's law? Yes, there are various applications. Actually, what it says that when we are switching on any device, after sometimes we will get that heat, isn't it? Even though you are watching mobile for a longer time, after sometimes you can feel the heat on the mobile, isn't it? Similarly, for refrigerators, for TV and all, this heat will be generated when it is used for a longer time. So, is these heats good? No, these are undesirable heat. Okay, undesirable heat is produced. That is also based on Joule's law. Okay, not only that, some desirable heat is also generated. Where the desirable heat can be seen? It can be seen in electric bulb. An electric bulb to glow, the heat has to be produced. Okay, before the electric bulb, that heat produced is the desirable one. And second one is electric fuse. Electric fuse will be cut when extra heat is produced. Okay, this is also the desirable one. And the third important thing is heating elements. That is iron box, then toaster, electric oven and all. For these purpose, heat has to be generated. With that, the appliances will work. So these are the desirable kind of heat. Now we are going to see how the Joule's law is working for these devices. Okay, we are seeing the practical applications of this Joule's law. The first one is electric bulb. Have you seen the electric bulb? In the electric bulb, when it is off position, we can see a small metal inside the bulb, isn't it? Have you seen the small metal inside this bulb? This metal is called tungsten. It's pure metal. What is the specialty of the metal? It is having high melting point. Not just high melting point, it is having very, very high melting point. That is about 3350 degrees Celsius. Only when the temperature is reaching to that extent, it will break. Okay, then only it will melt. Okay, so when the electric current is switched on, when it reaches this tungsten metal, it starts to glow, which generates what, ma? Light effect. Okay, we have seen this bulb. This bulb is made of what, ma? It is made of glass, and inside it will be filled with argon or nitrogen even. Why they are filled? Because to resist the corrosion for this tungsten metal. This is the working principle of electric bulb. Now we are going to see about the fuse. What is the specialty of this electric fuse? This electric fuse is made of metals or alloys which is having very low melting point. Okay, they are having very less melting point. So what happens is, when a high electric current is passed through this metal will melt. This alloy will melt. So what happens? The electric circuits will be broken down. So the electric devices which are connected along with it will not be having this high electric current, so that they will be saved from what? From getting damaged because of the high current. Actually, this electric fuse is acting as what, ma? Safeguard for these electric devices. Fuse wire is made of tin or lead. And the third is heating elements. Heating elements, there are various heating elements in which the heat is working. Okay, for example, iron box. When the iron box gets heated, then it will be able to iron our clothes, isn't it? Then electric toaster. The toaster should get heat for making our bread in a toasted manner, isn't it? Similarly, electric dryer, or it also generates heat. Okay, for these things or these equipments, heat is required. Okay, so much more heat is needed. It all made of alloys which are having high resistivity. If the resistivity is high, what happens? The resistance also will be high, because we have already learned that resistance is directly proportional to the resistivity of the material. These heating elements are all made of the alloy called nichrome. Nichrome is the one which is having high resistivity. So it offers, when the electric current passes through this heating element, what happens? Much more heat will be generated, and thus these equipments will work accordingly. Okay, ma? So this is the heating element. These are the applications of Joule's law. So what are they? Electric bulb, electric fuse and heating elements. Now the next topic is about what, ma? About the electric power. What is the equation for the electric power, and how can we derive this electric power, and how can we relate this electric power with voltage and current? All these we are discussing here. We all know that what is the equation for power? Power is equal to what? Power is equal to energy by time, isn't it? Power is equal to, it is the ratio of energy and time. In this case, amount of energy is equivalent to what, ma? Work. So we can rewrite the power equation as W by T. Okay, W by T we can write. Now we are changing W and changing the value of T also. We already know that voltage is equal to what, ma? W by charge. Work done by charge. This is volt. So can you equate W? W is equal to VQ. So here we can apply P is equal to what, ma? VQ by T. Isn't it? PQ by T. But we know Q by T is something else. What is that? Charge by per unit time is what, ma? It is current. Q by T is equal to what, ma? Current I. So this P will be is equal to what, ma? V into I. This is an equation for power. P is equal to what, ma? VI or IV. Now we can again simplify it. We already know according to Ohm's law, V is equal to what, ma? V is equal to IR. So I am changing the V as IR. So P is equal to, instead of V, I am substituting IR. So what it will be? I is equal to what? I square R. It is again an equation for power. And similarly, we can change the value of I. According to Ohm's law, I is equal to what? V by R, isn't it? I is equal to what, ma? I is equal to V by R. Here I am substituting. P is equal to V into V by R. So it will be a what, ma? V square by R. So what are the equations for power? Power is equal to VI, power is equal to I square R, and power is equal to V square by R. Like that, according to the question, what is given in the numerical question, accordingly we can find out power. Now yet another topic is commercial unit of energy. For factories, for schools, for industries, for household work, and for all many other works, this electric energy is used, isn't it? So we are using this electrical energy in a commercial way, commercial manner. So the electric energy is having some another unit other than this joule or erg. What is that? It is kilowatt hour. This is the commercial unit of energy. How we get this kilowatt hour? We know what is the equation for power. Power is equal to what? Normally we say that energy by time, isn't it? So what is the energy? Energy is equal to power into time. Okay. What is the unit of power? Unit of power is watt. What is unit of time? Unit of time is second. So energy's unit can be watt second. But as we are using the electrical energy in a higher amount, it has been changed as kilowatt. Kilowatt into, for the time, seconds has been changed to what, ma? Hour. Thus we got the commercial unit of energy. What is the commercial unit of energy? Kilowatt hour. So how much is 1 kilowatt hour? What is 1 kilowatt energy? We are comparing this 1 kilowatt energy in joule. What is the SI unit of energy? Usually the SI unit is joule. So we are equating kilowatt hour and joule. We know 1 kilowatt is how many watt, ma? 1 kilowatt is 1000 volt. 1 kilowatt is equal to 1000 watt. Okay. 1 hour is equal to how many seconds? 3600 seconds, isn't it? So 1 kilowatt hour is equal to what, ma? Equal to what, ma? 3600 into 1000, isn't it? 3.6 into 10 raised to 6 joule. So 1 kilowatt hour is equal to what, ma? 3.6 into 10 raised to 6 joule. This is how we can calculate the energy, commercial unit of energy. So 1 kilowatt hour is how many joules ma? 3.6 into 10 raised to 6 joules. Now the last topic is about the efficiency of electric device. How can we say an electric device is efficient or inefficient? By checking the power. How? Actually, the efficiency of an electric device is the ratio of useful power output by power consumed. How much power which it has been emitted to how much power it consumed is what it is the efficiency. Efficiency should be always represented in the form of percentage. So how can we represent efficiency? Efficiency eta. This is the simple. This is equal to power output divided by power input into 100%. If this value is very high, which means what? That device or that equipment is having high efficiency. If this value is comparatively low, the efficiency of this device is very less. We will understand. Okay. This is what efficiency. This is a small topic, and based on that numericals may come. That's why this is giving stress. Now we are going to have the question time. Are you ready? The first question is, ammeter is connected to the electric circuit in dash manner, series manner or parallel manner. Is the ammeter connected in a series way or in parallel way? Second one is, it's very easy one. 1 kilowatt hour is equal to dash joule. 1 kilowatt hour is equal to dash joule. Third one, in electric heater, which alloy is used? In electric heater, dash alloy is used. Okay. These are the questions, and I think it's very easy for you to answer. You can write the answers in the comment box, and we will meet in the next class. Bye.